What is a protocol? Protocol is a standard set of rules that allows electronic devices to communicate with each other. These rules include what type of data may be transmitted, how it is structured, what commands are used to send and receive data, and how data transfers are confirmed. And also, when it comes to protocol, there are different standardized and established set of rules published by different bodies around the world. Now we will look at what is the importance of standards. A standard can be thought of an agreed upon norm used by people, industry and government that are outlined the best way to complete a task, whether it's developing a product, providing a service, controlling a process. So the technology standard can also provide a framework that enables devices from different manufacturers to communicate with one another. When it comes to consumer and businesses are confident that products will work as expected, they are far more likely to buy them. Standards-based interoperability and also gives them freedom to mix and match different manufacturers. Standards also make it easier to understand and compare the competing products. As standards are globally adapted and applied in many markets, they also fuel international trade. Then we will look at few international bodies. ITA, Telecommunication Industry Association, ETSI, European Telecommunication Standard Institute, ITU, International Telecommunications Unions, are few of authorized bodies or standard bodies which already have implemented standardization for wireless communication. Then we will look at what is the relationship between IEEE and ETSI. IEEE stands for Institute of Electrical Engineers, is an international body that specifies industry standards for power consuming electronic computers, including computer communications. The ETSI is European Telecommunication Standard Institute, is a European body that is specifically formed for telecommunication standard within Europe. It is almost the IEEE version of European. Then we will look at few standards which were developed by IEEE. IEEE 802.11, also known as Wi-Fi, is a wireless technology that has become a critical component in today's networking world. It is used virtually everywhere people need internet access, including wireless networking in homes, school, campuses, airports, offices, businesses, stadiums, parks, and shops. In addition, 80.11 provides mobile operators with wireless LAN offload, allowing them to satisfy high bandwidth data requirements of their customers, capable of operators using wireless LAN technology to extend availability of their network through their customers' home and neighborhood. So if we look at few standards, 801.11 which uses 2.4 gigahertz frequency with up to maximum speed of 2 megabits per second. Then we have 802.11a which uses frequency of 5 gigahertz and it has a maximum speed of 54 megabits per second. Then we will there are 802.11b, 80.11g and 802.11n. It is a little bit special because it uses both frequencies such as 2.4 gigahertz to 5 gigahertz and it has a maximum speed up to 600 megabits per second, and then the newest one we can say it's 02.11 AC, which uses 5 gigahertz frequency, and it has maximum speed up to 1 gigabits per second. Then we will move on to the next subject, next topic. The next topic is the 7 layers of ISO. So we will look at this from top to bottom. Application layer. The application layer is used by end user software such as web browsers and email clients. It provides protocols that allow software to send and receive information and present meaningful data to the users. A few examples of application layer protocols are the Hypertext Transfer Protocol, or very much known as HTTP, File Transfer Protocol (FTP), Post Office Protocol (POP), Simple Mail Transfer Protocol (SMTP), and Domain Name System (DNS). Then we will move on to presentation layer. The presentation layer prepares the data for the application layer. It defines how two devices should encode, encrypt, and compress data so it receives correctly on the other end. The presentation layer takes any data transmitted by the application layer and prepares it for transmission over the session layer. Then we will look at the session layer. Session layer creates communication channels called sessions between devices. It is responsible for opening sessions, ensuring they remain open and functional while data is being transferred, and closing when the communication ends. This session layer can also set checkpoints during the data transfer. If session is interrupted, device can resume data transfer from the last checkpoint. Then we will move on to transport layer. Transport layer takes data transfers in the session layer and breaks it into segments. On the transmitting end, it is responsible for reassembling the segments at the receiving end, turning it back into data that can be used by session layer. The transport layer carries out flow control, sending data at a rate that machine and connection speed of the receiving device, and error control, checking if data was received correctly. If not, request it again. Then we will move on to the network layer. Network layer has two main functions. One is breaking up segments into network packets and reassembling packets on the receiving end. The other is routing packages by discovering the best path across the physical network. The network layer uses network addresses, typically Internet Protocol addresses, to route packets to a destination node. Then we will see the next layer, data link layer. Data link layer establishes and terminates a connection between two physical connected nodes on a network. It breaks up packets into frames and sends them from source to destination. This layer is composed of two parts: logical link control, which identifies the network protocols, performs error checking and synchronizes frames, and media access control, which uses MAC addresses to connect devices and define permissions to transmit and receive data. Then the final layer, physical layer. The physical layer is responsible for cable and wireless communication between network nodes. It defines the connector, the electrical cable or wireless technology connecting the devices, and is responsible for transmitting the raw data, which is simply a series of zeros and ones, while taking care of a bitrate control. Then we will look at the layers and the functions of TCP/IP protocol suite. First one is the application layer. The application layer provides application with standardized data exchange. Its protocol, including the management of HTTP, FTP, POP3, three SMTP and simple network management protocols at the application layer. The payload is actually application data. Then we will look at the second layer, the transport layer. The transport layer is responsible for managing end-to-end communication across the network. TCP handles communication between host and provide flow control, multiplexing and reliability. The transport protocol includes TCP and user diagram protocol, which is sometimes used instead of TCP for special purposes. Then we will see the third layer, the network layer. The network layer is also called the internet layer, delays the packet and connects independent networks to transport the packet across network boundaries. The network layer protocol are the IP and the internet control messaging protocol, which used for error reporting. Then we will look at the last layer, network access layer, or it is also known as physical layer. Network access layer is also known as the physical layer or the data link layer, consists of protocols that operate only on link, the network component that interconnects node and host in the network. The protocols in the lowest layer include Ethernet for local area network, known as LANs, and address resolution protocol, ARPs. Then we will look at what is the relationship between ISO OSI 7 layer and TCP IP protocol suite. The most difference between OSI and TCP IP layer is the layers which it has. Usually when we talk about OSI layer, we have 7 layers, but with TCP IP we have only 4 layers. Since we have already discussed what are the applications and uses of these layers, we will now compare and contrast them. The similarities, if we talk, both models are based on logical models. They define network standard. They divide the network communication processes in layers. They provide frameworks for creating and implementing network standards and devices. They enable one manufacturer to make devices and network components that can coexist and work with the devices and components made by other manufacturers. So even they have similarities, they also have differences. Such as TCP IP uses one layer for application to define the functionalities of the upper layers, while the OSI mode uses 3 layers like application, presentation and session to do the same function. The TCP IP model uses one layer, link layer, to define the functionalities of the bottom layers, while OSI uses 2 layers, physical and the data link layer. TCP IP model uses the internet layer to define the routing standard and protocol, while OSI uses network layer. The TCP IP header size is 20 bytes, while OSI header size is 5 bytes. TCP IP model is protocol oriented standard, whereas the OSI model is a generic model based on the functionalities of each layer. TCP IP follows a horizontal approach while OSI follows a vertical approach. In the TCP IP suite, the protocol were developed first and then modes were developed. In the OSI, the modes were developed first and then the protocols in each layer were developed. So in TCP IP helps to establish connection between different types of computers, whereas OSI modes help to standardize routers, switches, motherboards and other hardware. Then we can look at pros and cons of TCP IP. The advantages of using TCP IP model include the following. It helps to establish connection between different types of computers, work independently of operating systems, supports many routing protocols, has client-server architecture that is highly scalable, can be operated independently, supports several routing protocols, and it is lightweight and doesn't place unnecessary strain on network or on computers. And also there are some disadvantages of TCP/IP suite. It is complicated to set up and manage. Transport layer doesn't guarantee delivery of packets. It is not easy to replace protocols in TCP/IP. Doesn't clearly separate concepts of services, interfaces, protocols, so not good for descripting new technologies in the network, and especially vulnerable to synchronization attacks, which is a type of denial of service attack which a bad actor uses TCP/IP protocol. Then we will move on to the next session. We will look at about signals. What is an analog signal? An analog signal is a continuous signal that changes depending on the time. An analog signal is any continuous signal for which the time varying feature of the signal is representation of some time varying quantity. For example, analogous to analog time varying signal. For example, for an analog audio signal, the instantaneous voltage of the signal varies and continues across the time field. Then we will see what is a digital signal. Digital signal is a representation of a signal that has two ends, such as high end and low end, which is represent data as a sequence of discrete values. At any given time, it takes on at most one infinite number of values. This contrasts with an analog signal, which represents continuous value at a given time. It represents a real number within a continuous range of values. Then we will look at the qualities of a signal. First one, we can say the amplitude of a sinusoidal signal. Amplitude specifies the maximum distance between horizontal axis and the vertical position of the waveform. A sine wave of amplitude of 5 volts, for example, it has value of +5 and -5. Then the frequency tells us how quick sinusoidal completes a full cycle. This is one of the most important characters, influences the maximum rate at which a sinusoidal signal can be transmits information and determines how sinusoidal signal will be affected by circuits that includes capacitors and inductors. The third one is the phase, which refers to the horizontal position of the waveform with respect to one cycle. It is easier to understand that the context of the phase shift or phase difference. We use these terms to describing extent which one of shift by angle with the theta to indicate the shift. Then we will look at the bandwidth of the signal. When we look at the bandwidth of the signal, it defines as the difference between upper and lower frequencies of a signal generated. As seen in the form, you can see the lowest frequency is FL, highest frequency is FH. So the representation bandwidth is FH minus FL, which is measured by hertz. Then we will look at how to find out the maximum allowable bit rate of a lossless transmission media and lossy transmission media. Data rate depends on three factors: They are the bandwidth, availability, number of levels of digital signal, the quality of the channel, level of noise. To determine this, we have two major laws. For noiseless channels, we use Nyquist theorem, which defines bitrate by 2 into bandwidth to log to L. For noisy channel, Shannon capacity law is being used. It shows capacity equals bandwidth into log 2 plus 1 SNR. Then we will see what is the impairments such as attenuation, distortion and noise. The signal is received many differ from when a signal is received different from the signal transmitted, it is called that the transmitted signal has been affected. This effect degrades the signal quality for analog signals and induce bit errors for digital signals. There are three types of transmission impairments. First one we can say attenuation. The impairment is caused by the strength of signal degrades with a distance over the transmission link. Then if we look at the second thing, we can say the distortion. Distortion is acoustic in electronics. In any changes of signal that alerts the basic waveform from the relationship between various frequency component, it is usually degrade the signal strength. Amplification of attenuation without altering the waveform is not usually considered to be distortion. Then finally we can have noise. Implementation occurs when an unwanted signal is inserted between transmission and the reception. Then we will look at what is the latency of a signal. Latency of a measure of a delay. In a network, latency is measured by time taken from some data to get to the destination across the network. It is usually measured as round trip delay, the time taken for information to get it to its destination and to come back. Then we will look at the PCM process. PCM is very well known method for modulation. It is pulse code modulation, which stands for PCM, a method used to digitally represent sampled analog signal. It is the standard form of digital audio in computers, compact disc, digital telephony and other audio applications. In PCM stream, the amplitude of the analog signal is sampled regularly at uniform intervals and each sample is quantized. We can say some implementers like as digital audio, the telephone systems, compact disc, laser disc. Then if we look at the modulation part, we have first modulate with using ADC and then demodulate it with using a DAC. Since it is, we have to sample the analog signal, then convert it to a digital signal, then we have to convert digital signal into analog signal in order to reconstruct the signal. Then we will look at two low rate encoding methods. Harmonic coding. Low bitrate good quality speech coding is one of the most fundamental goals of today's speech processing research. Present day coding technologies like PAC and ATC can achieve good quality transmission only down to about 12 kilobits per second. Below this rate, the quality degrades rapidly. On the other hand, the various kind of occaders, which operates up to about 5 kilobits per second, have inherent quality limitation which cannot be overcome by increasing the bit rate. In this new coding scheme, which is based on recently developed spectral mode of non-stationary voice speech, and its form the basis of a waveform coder and vocoder, which are introduced in this harmonic coding and which shares the same basic structure. Experimental results are presented which shows the both system will significantly bit rate reduce relevant to present day scheme. Then we will look at vector quantization, VQ, sub-band coding, SCB, and linear predictive coding, LPC, are three of the most effective data compression schemes used for medium to narrow band speech coding. Then we will look at modulation. Modulation is a process of converting data into radio waves by adding information to an electronic or optical carrier signal. One of the main methods of modulation is QPSK. It is quadrate phase shift keying. Is a form of phase shift keying in which two bits are modulated at once, selecting one of four possible carrier phases at 0, 90, 180 or 270 degrees. QPSK allows the signal to carry twice as much as information as ordinary PSK using the same bandwidth. And another very popular method is 64QAM. 64QAM is a higher order modulation technology which allows one single radio wave to represent 6 bits of data by manipulating the amplitude and phase of a radio wave into one of 64 different discrete and measurable states. Then we will look at multiplexing. FDM, known is stand for frequency device division multiplexing, is a technique by which the total bandwidth available in a communication medium is divided into a series of non-overlapping frequency bands which is used to carry the signal. Then the TDM. TDM, time division multiplexing, is a method of transmitting and receiving independent signals over a common signal path by means of synchronized switches at each end of the transmission line, so that each signal appears on the line only on fraction of a time in an alerting system. OFDM, orthogonal frequency division multiplexing, is a form of signal wave modulation that provides some significant advantages over the data link. Accordingly, FDM is used for many of the latest and high bandwidth with high data rate wireless system, including Wi-Fi, cellular telecommunication, and many more. Then we will look at MIMO, beam folding, FDD, and TDD. MIMO, multiple input, multiple output, is a method for multiplying the capacity of a radio link using multiple transmission and receiving antennas to exploit multipath propagation. Beamforming is a technique that focuses a wireless signal towards a specific receiving device rather than having signal spread in all directions from broadcasting antenna as it is normally would. The resulting more direct connection and it is much faster and reliable. Then FDD is frequency division duplexing is a technique where the transmitter and the receiver operates at different carrier frequencies. For instance, mobile wireless networks, one block of spectrum is allocated for uplink, which carries data from mobile phones to base station, while other allocates for downlink. Then TDD is time division duplexing, uses single frequency band for both transmission and receive. Then it shares that band by altering the time slot to transmit and receive operations. The information to the transmit, where the voice, video or computer data is in a serial binary format, which time slot may be 1 byte long. Then we will look at what is the difference between data word and code word. Cryptology is a study of secret writing. Cryptology is the study of how to create systems that convert plain text into ciphertext. Here are typical two different types of this systems discussed: code and chippers. A chipper is a cryptographic system where a signal united letter block of bits, a signal bit, is converted into new cynetic unit either by substituting or transposing or by using both. A code is cryptographic system where large synaptic unit, word, phrase or entire sentence are converted into code words via substitution of a code book. Then we will look at how the errors can be detected from block coding. In case of following these two conditions, we can detect errors in the block coding. If the receiver has a list of valid code words, the original code words has changed into an invalid one. How the errors can be corrected in block coding? Error correction is much more difficult than error detection. In error detection, the receiver needs to know only that the receiver code word is invalid. But in error correction, receiver needs to find or guess the original word code sent. So we need to do more redundant bits for error correction than for error detection. Consider the following table. It consists of data word and code word. Assume that the data word is 01. The sender concludes the table to create the code word 01011. The code word is corrupted during the transmission and 01001 is received. Error in the second bit from the right. First, the receiver finds that the receiving code would not be in the table. This means an error has occurred. Detection must come from the correction. The receiver, assuming that there is one bit corrupted, uses the following strategies to guess the correct word. Compare the receiving code with the first code in the word in the table. It is 01001 versus 0000. The receiver decides that the first code word is not the one that was sent because there are two different bits. By the same reasoning, the original code word cannot be the third or fourth in the table. So the original code word must be the second one in the table, because the only one that differs from the receiver code by 1 bit is the third one. So it replaces 0 1 0 0 1 with 0 1 0 0 1 and concludes the table to find the error. Then we will look at cyclic code. In coding theory, a cyclic code is a block code where the circular shift of each code word gives another word that belongs to code. They are error correcting codes that have algebraic properties that are convenient for efficient errors detection and correction. Checksum is a small size block of data delivered from another block of digital data for the purpose of detecting errors that may have been introduced during its transmission or storage. By themselves, checksums are often used to verify data integrity but are relied upon to verify data authenticity. Then if you look at transmission buffer is the function of a transmission which helps to keep the output rate of the encoder fixed. If the buffers start filling up faster than the transmission rate, it sends a message back to the transform coder to reduce the output from the quantization. Receiver buffer. The TCP receive buffer is how much data can be buffered on the recipient's end. Normally, TCP stack will not allow data to be sent if it has no room for it at the receiver's buffer. The importance of flow control. Flow control is important because of it is possible for a sender to transmit information at a faster rate than the destination can receive it and process it. Then we will look at the HCDL protocol. HCDL protocol stands for High Level Data Link Control. Is a bit-oriented code transparent synchronous data link layer developed by International Organization of Standardization ISO under ISO/IEC 13239.2002. It provides both connection-oriented and connectionless services. DLC can be used for point to multipoint connections via original master-slave modes, normal response mode, asynchronous response mode, but they are now rarely used. In general purpose protocol, which operates at the data link layer of ISO reference model, the protocol uses services of physical layers and provides either the best effort or reliable communication path between transmission and receiver. How CSAM and CA protocols work. Carrier sense multiple access with collision avoidance. In computer networking is a network multi-access method which is carrier sensing is used, but nodes attempting to avoid collision by beginning transmission only after channel sense is sensed to be ideal. To deal with collision, carrier sense multiple access is collision detection is used in it as MAC protocol. For collision detection, every node monitors the bus while sensing data. If the data on the bus is different to the data node is currently sending, a collision is detected. Then Why LAN needs additional layers such as a MAC layer. MAC layers is responsible for moving data packets from and to one network interface card to another. Different protocols are used for different shared networks such as Ethernet, token rings, token buses, and WANs. The MAC sublayer uses MAC protocols to ensure that the signal sent from different stations across the same channel that doesn't collide. Then we will look at the functions of LLC layer. LLC is the data link layer divided into two sublayers, logical link control and sublayer provides the logic for the data link. Thus it controls synchronization, flow control and error checking function of the data link layer. The logical link control LLC data communication protocol layer is the upper sublayer of the data link layer. LLC sublayer acts as interface between media access control sublayer and the network layer. It provides multiplexing and mechanisms that makes it possible for several networking protocols. It can also provide flow control, automatic repeat request and error management mechanisms. Then we will look at the frame format of LLC. As you can see in the diagram, it consists of two types. It is DASP, Destination Service Access Point, which has 8 bits, and it has a source service access point which also has 8 bits, and the control has 8 or 16 bits. And there are three major types of frames: iframes, supervisory frames and unnumbered frames. Then we will look at the frame structure of IEEE 802.3 MAC frame structure. Frameable is Ethernet frame that starts with 7 bits. This pattern is alternate zeros and ones, which indicates starting of frame and allows sender and receiver to establish bit synchronization. Then the destination address. This is 6-byte field which contains the MAC address of the machine for which data is designated. Then SFB, which is start of frame designation. This is 1-bit field which allows to set SFB indicates. Then the source address. This is a 6-byte field which contains the MAC address of source machine, as source address is always an individual address. Then the length is 2-bit field which indicates the length of entire Ethernet from. This 16-bit field can hold the length value between 0 to 65,534, but length cannot be larger than 1500 because of some own limitations of Ethernet. Data. This is the place where actual data is inserted, also known as payload. Both IP header and data will be inserted here if the Internet protocol is used over Ethernet. The maximum data presentation may be as long as 1500 bytes. In case of data length is less than the minimum length, for example 46 bytes, the padding 0 is added to meet the minimal requirement. Then the CRC is the cyclical redundancy check, is a 4-byte field. This field contains 32 bits hash code of data. Then we will look at access point architecture, basic service set. and extended service sets. Access point architecture is a device that contains IEEE 802.11 conformant MAC and physical interface to wireless medium and provide access to a distribution system for associated systems. Most often infrared structured products that connect to wired backbone implemented via wireless IEEE 802.11 PC card when is inserted in an AP500 or AP1000. Then we will look at basic service set, a set of station controlled by single coordination function, similar to a cell in IEEE terminology. BSS has an access point both in standalone networks and in building-wide configurations, or can run without access point. Then extended service sets, a set of one or more basic services interconnected by distribution system. Traffic always flow via access point. Diameter of cell is double the coverage distance between two wireless stations. Then the structure of IEEE 802.11 MAC layer with including the sub layers. And it is the end. Thank you for listening. Thank you.